geometric series. In this section, I will solve a few problems with geometric series. Let's start with a quick look at the formula. That means the geometric series is a series with a constant ratio between successive terms. A is the first term, and then in order to obtain the next one, we have to multiply by a common number which we call common ratio R, A times R. And again, multiplying by R, we have A times R cubed, R squared. And then R cubed, R to the power of 4. That we can see we do have R to the power of 1, 2, 3, 4, and so on, but we did start with 0. That means the general formula is a sigma notation, starting n equals to 1, and then A as a first term, and the common ratio taken to the power of n minus 1, which with starting point 1, this is 0. 1 minus 1 is 0, and we do have the first term defined for 0. If I want to change my starting point n equals to 0, then this must be only n. If it's any other numbers, n equals to 3, for example, n minus 3 will also give me 0, 3 minus 3. Okay. That means this is about the sigma notation. In order to recognize the geometric series, we can see that the common ratio is taken to the power of n. If we see n in the exponent, most likely is the geometric progression, geometric series. One more time, A is the first term and R is the common ratio. In order to compute a common ratio, I can take, for example, the second term and divide by the first one. Or I can take any term, let's say the ninth one, and divide by 1 before. Or I can take n plus 1 term, divide by n. I will always get the same number, R. The geometry, in order to be, the geometric series could be convergent or divergent. For the geometric series to be convergent, the common ratio must be less than 1 or greater than -1. That means if the common ratio is less than 1 or greater than -1, and this is the same notation using the absolute value, then the geometric series is always convergent. The sum is finite. If the common ratio is from that interval, we can compute the sum using this formula, A over 1 minus R. But this formula only works if R is between -1 and 1. If R is outside this interval, then the geometric series is divergent. Exercise number 1. Find the sum of the geometric series. 5 minus 10 over 3 plus 20 over 9 minus 40 over 27, and so on. I'm assuming that the pattern will continue without a change. And let's check if this is the geometric series, first of all. That means I can see that my first term is 5, and the common ratio will be, for example, second term divided by the first one. -10 over 3 divided by 5. -10 over 3 dividing by 5 means multiplying by 1/5. -2 over 3. I can simplify 5 and 10. -2 over 3. That means this is a number between -1 and 1. That means this geometric series is definitely convergent because the common ratio is -2 over 3, and this is definitely between +1 and -1. Or I can say absolute value, it's less than 1. Just to double check, I can also pick possibly the fourth term and divide by the third one. but we definitely know that this is the geometric series because that was stated in the question. Let's take the fourth term. It's negative 40 over 27 divided by 20 over 9. Negative 40 over 27 divided by 20 over 9 means multiply by 9 over 20. I can see some simplification, 40 and 20, 1 and 2, and 9 and 27, 1 and 3. And the answer is negative 2 over 3, which of course is the common ratio must be the same. Okay, that means now, since is the convergent, this geometric series is convergent, I can find the sum. A, 1 minus r. A, the first term is 5, 1 minus negative 2/3. 5, 1 plus 2/3, 5, this will be 5 over 3, and 5 multiplying by 3 over 5, I think I'm getting 3 only. I can simplify, of course. That means the sum is 3. And actually, I do have a graph. I have a numerical value. That's the numbers of the partial sum. We keep adding terms, and we getting the number close to 3. That means we saw also that was alternating one. We were adding and subtracting numbers. That means adding, subtracting, adding, subtracting. We getting numbers small, but they oscillate between 3. And that's the sum. Exercise number 2. Determine whether the series is convergent or divergent. If it is convergent, if it converges, find the sum. That means, first of all, looking at this formula, I see n placed in the exponent only. That means I'm assuming that is the geometric one. And we have a few different ways. That means, first of all, I can change a little bit. N, if the sum starts from n equals to 1, and I see 2 to the power of 2n, which is 4 to the power of n, and 3 to the power of 1, and 3 to the power of negative 1. I'm not going to change completely, but I will rewrite a little bit. Now I can put 4 to the power of n and 3 to the power of n, and I can keep that 3. Actually, I can even change 3 as a first term and 4 over 3 to the power of n. And I did change a little bit, and actually I got nice form. It's not really the general form of the geometric series, because if I will expand this, my first term is not really 3, because this is not n minus 1. Of course, I can expand and I can see the first term, which I will do. But what I can see, the number that is taken to the power of n only is 4 over 3. No other parts of the formula is taken to the power of n. That means to the power of n is then taken the number 4 over 3, and that's my common ratio. Okay? Even from the original one, I can see right away that I have 2 to the power of 2n, which is 4 to the n, and 3 to the negative n, which this will go to the denominator. That means the quantity 4 and 1/3, 4 over 3 is taken to the power of n. That means this is one way to recognize the common ratio. And I can write right away that the common ratio is 4 over 3 and is greater than 1. This series is divergent. And that means this is telling me that the series diverges. Okay. One thing that I would like to do, I would like still to just to expand. Because having that form that I change, again, I see right away, it doesn't really matter what is the exponent, this is always a common ratio. But since this doesn't really match to my general formula, this is not my first step. That means first term is 3 times 4 over 3 to the power of 1, because we're starting from 1. And then 4 over 3 to the power of 2, 3, 4 over 3 to the power of 3, and so on. Okay? That means just to make sure what is the first term is 4. Okay? Just in case, if we will get convergence and we have to compute a sum. Okay? That means please note that it's not really 3. We can simply expand, list the terms, and take the first number. That's the first step. Okay, exercise number 3. Determine whether the series is convergent or divergent. If it converges, find the sum. Okay. Now, the sigma, the summation, starts from 0 to infinity and goes off to infinity. And the formula is 6 times 3 over 5 to the power of n. That means again, I recognize that it's geometric one because n is placed in the exponent and no other n's around and no expanded form. And the only quantity that is taken to the power of n is 3 over 5. That means this is my common ratio. And this is less than 1. This infinite series is definitely convergent. And I can find the sum. The sum is A1 minus the common ratio. The first term, and again, please do not guess. We can see that this actually matches to my general formula, but we don't have to memorize. We can simply pay attention that the first term is defined for n equals to 0, and we can expand this. That means the first term is 6, 3 over 5 to the power of 0. And then the next one will be 6, 3 over 5 to the power of 1, and 6, 3 over 5 to the power of 2, and so on. Okay, that means that's the following terms. And this one is the first one, which means 3 over 5 to the power of 0 is 1. 6 is the first term. But again, please do not guess. Put this as a n for the first term and compute it. That we do have 6, 1 minus 3 over 5. 6, 2 over 5. And if I flip the number, 5 times 6 is 30 over 2. The sum is 15. Infinite series converges to 15. Adding terms, we're getting a finite sum not bigger than 15. Okay, multiple choice question. Determine whether the series converges or diverges. If it converges, find its sum. We have few options. Okay, that means again, I see a sigma starting from 1 and goes off to infinity, and the formula is 3 negative 4 to the power of n minus 1 over 5 to the power of n. That means, first of all, I see n placed in the exponent only. That means I'm assuming that it's geometric series because it's the common ratio changing. Each term is multiplied by. And what I see now quantity negative 4 to the power of n, and I see 5 in the denominator to the power of n. That means my common ratio is negative 4 over 5. And you can see that's the easiest way to get the common ratio, negative 4 and 5. Now I can list terms. That means I will have 3, negative 4, and 5, and the first term is defined for n1. That means I will put 1 instead of n. And then the second term will be negative 4 taken to the power of 2 minus 1. I can just use different color instead of n, 2, and so on. And that means I can compute all of the terms. And let's compute the first one. Negative 4 to the power of 0 is 1. That means 3 over 5. And this will be actually negative 4 to the power of 1 will be negative 1. I can keep 3 and negative 1, 5 to the power of 2. Or I can even change that. Okay, and then another one, we will not compute. And having the first term and the second term, you can try to divide this, the second one, by the first one. You will get the common ratio. But one more time, to avoid this arithmetic, you may just pull out numbers taken to the power of n. Negative 4 and 5, numerator and denominator. And my first term, actually, that was my point, is 3 over 5. And we can see simply substituting instead of n, 1. And we can see that common ratio is the absolute value of the common ratio. It's definitely less than 1. Then the infinite series is convergent. Let's find the sum. A minus r. A is 3 over 5, 1 minus negative 4 over 5. Okay, 3 over 5, and adding, we will have 9 over 5, because I will add 1 plus 4 over 5, which is of course 9, and 3 over 9, which is 1/3. And I did, of course, this, and then I simplify. That means my final answer is 1/3. The infinite series converges to 1/3. I can write converges to 1/3. Exercise number 5. Determine whether the series is convergent or divergent. If it is convergent, find its sum. And again, we do have few options. The last one is telling me that it's divergent. Let's see. That means now, looking at the formula, the sigma from n equals to 1 to infinity, and then I have negative 1 to the power of n plus 1. And actually, I do have addition plus 2 to the power of n minus 1 over 3 to the n. The only thing is, I can say, yes, this is the geometric one, because n is placed in the exponent only, in the power. But the plus is a little bit not helpful at the moment. That means what I can see, how can I interpret this? I can see this as an addition of 2 geometric series. That means let's split, and then let's get 2 sums, add them together if they exist, of course, and get the final answer. That means this infinite sum series, sigma from 1 to infinity, can be split for 2 of them. Negative 1 to the n plus 1 over 3 to the n, and plus, that's the addition, another sigma from 1 to infinity, 2 to the n minus 1 over 3 to the n. Okay? As we can see, we do have 2 of them, because we don't really expect any addition, subtraction, and expanded form in the geometric one, because we have to have a common ratio, product, multiplication. Okay, that means the first one, I see negative 1 to the n, and of course plus 1, but I will take care of this later. But definitely negative 1 is taken to the power of n, and 3 is taken to the power of n. Negative 1/3 is the common ratio for the first one. For the second one, I see 2 to the power of n, and 3 to the power of n, 2/3. Both of the numbers, both of the common ratio are less than 1 or greater than -1. Okay, they satisfy the convergence. That means both of the infinite series are convergent. Let's find the sum. We need a first term for both of them. Let's look at the first formula, -1 to the power of n plus 1 over 3 to the n. In order to compute a first term, I have to substitute instead of n, 1. That means -1 to the power of 2 will become 1, and this is the first term, 1/3. And then the same for this one, 2 to the power of 1 minus 1, 3 to the power of 1. 1 minus 1, 0, 2 to the power of 0 is 1, and 3. Okay, the first term is actually the same for both of them. Yeah. They look a little bit different, we can see, but the first term is 1/3 for the first one and 1/3 for the second one. Okay, let's find two sums because we will be adding these things. The first one, the sum is 1/3, which is I can write the formula somewhere. The sum is A, the first term, 1 minus the common ratio. That means the first one is 1/3, 1 minus the common ratio, -1/3. For the second one, the first term is also 1/3, 1 minus 2/3. That's the common ratio. Let's simplify the fractions, add them together, and pick the answer. That means answer E is definitely not good answer. Okay, this one is 1/3, 1 plus 1 over 3. And this one is 1/3, 1 minus 2/3 is 1/3. Okay, that means 1/3 over 1/3 is 1, but this one will be 1/4. 1/4 plus 1, 5 over 4. But maybe I can do this way. This will be 1/4 plus 1, 5 over 4. This geometric series converges to 5 over 4. But please note that I did split this. Okay? And I have one more. It's similar to the homework assignment. Determine whether the series converges or is convergent or divergent. If it converges, find the sum. That means it's quite similar that I just did to the exercise number 5, but I would say it's a little bit simple. Okay, I see a sigma starting from 1, 1 plus 3 to the power of n, and then 8 over 8 to the power of n. Again, I see n in the exponent, that means it is geometric one. However, the addition is asking me to split for 2, because I don't have addition in the geometric series. 1 over 8 to the power of n, and the second one is 3 to the power of n and 8 to the power of n. That means looking at the second one, I can definitely see that the common ratio is 3 over 8, because the 3 is taken to the power of n and 8 is taken to the power of n. No other numbers. That means they will change. Like 3 to the power of, 3 over 8 to the power of 1, 2, 3, 4, that's my common ratio. And then the first term, because I also noticed that this is less than 1, is definitely convergent. The infinite series is convergent. That means in order to get the sum, I will need the first term, and the first term is defined for n1. That means I'm substituting instead of n1, and I will have 3 to the power of 1, 8 to the power of 1, which actually is the same quantity like the common ratio. Just a coincidence. Okay, now this one, the common ratio is, for the first one, I see 8 to the power of n, but I can also place 1 to the power of n. 1 to the power of n is always 1. That means just a little bit easier to recognize the common ratio, I see 1 to the power of n and 8 to the power of n in the denominator. Okay, that's minus 1 over 8, which of course is less than 1, will give me a sum. And my first term is defined for n1, which actually is the same thing. Okay, let's put this together and let's find two sums and add them. This is the first one, this is the second one. Okay, the sum is defined, I can maybe skip this. The first term is 1a, 1 minus the common ratio, and we will be adding. The first term is 3 over 8, 1 minus 3 over 8, the common ratio is the same. 1 over 8, 1 over 8, and 7 over 8, 3 over 8, and 5 over 8. That's what I have. I can 8, I can simplify. 1, 7 plus 3 over 5. Now, we do have a little bit of arithmetic. 35 will be the common denominator, and I will multiply 1 times 5 and 7 times 3, 21. 26 over 35. That means this infinite sum converges to 26 over 35. I hope now you can practice the geometric one. You will never make mistake. You will always recognize the geometric. And of course, you can practice based on these examples. Thank you.